Assalamualaikum and hello everyone. So today our group will talk about rotary positive displacement pump, which is gear pump. So what is gear pump? A gear pump is a type of rotary positive displacement pump that moves fluid in a steady and smooth flow through the use of two rotating gears. It can handle a variety of liquids, including thick or chemically aggressive ones, and is reliable as well as simple to use. There are three main types of gear pump. The first one is external gear pumps, which use two externally toothed gears for high flow rates and pressures. The second one is internal gear pumps, which have a smaller internal gear inside a larger external gear for quiet operation and viscous fluids. And the third one is gyratory pumps, which use a rotor and idler gear for efficient fluid transfer. Due to their accuracy and small size, gear pumps find extensive use in hydraulic systems, chemically processing, food production, and also automotive applications. Next, we have the components of gear pump. As you can see on the picture here, we have 11 parts of gear pump components. The first one is suction port. Suction port is the inlet where the fluid enters the pump. It's located in a low pressure zone created by the rotation of the gears. Second one is case. It is the main housing that encloses the internal components such as gears and bushings. It provides a sealed environment to contain the fluid during pumping. Third one is drive gear. The gear is connected to the drive shaft that rotated to drive the pumping action. It engages with the idler gear to create the meshing motion required to move fluid. And the fourth one is idler gear. It is the secondary gear that rotates in response to the drive gear's motion. It works in tandem with the drive gear to trap and move fluid between the gear teeth. The fifth one is drive shaft. It is the shaft connected to an external motor or power source. It transmits rotational motion to the drive gear. Continue about the components part. Sixth one is seal. It prevents leakage of fluid along the drive shaft and protects internal components from external contaminants. The seventh one is case cover. It's a removable part of the casing that allows access to internal components for maintenance or repair. It's secured with bolts and includes a case seal to prevent leakage. The eighth one is case seal, a gasket or O-ring located between the case and the case cover to ensure a fluid-tight seal. The ninth one is bushings. It supports and guides the rotation of the gears and shaft. It reduces friction and wear on the moving components. 10th one is pressure pump, the outlet where the pressurized fluid exits the pump. It located in a high pressure zone created by the rotation of the gears. And the last one is mounting flange. It is a structural component that allows the pump to be securely mounted to a base or a system.
Operational principle of gear pumps. Let me explain how gear pumps work, focusing on three main types: external gear pumps, internal gear pumps, and gyratory gear pump. Each type operates on the same basic principle of using rotating gears to transfer fluids, but they differ in their designs and functionality. First, external gear pump. External gear pumps have two identical gears: the power gear, which is connected to a motor or engine, and the driven gear, which rotates in the opposite directions. Here's how they work. On the suction side, as the gear teeth move apart, the spaces between them increases. This creates a vacuum, which draws the fluid into the pump. The fluid becomes trapped in the spaces between the teeth and the inner wall of the pump housing. As the gear rotate, they carry the trapped fluid along the edges of the pump from the inlet to the outlet. Finally, at the discharge side, the gear teeth re-engage, reducing the available space. This forces the fluid out of the pump at high pressure, thanks to the tight tolerances between the gears and the pump and the housing. External gear pumps prevent backflow. Tough, low viscosity fluids might experience slight leakage. These pumps are versatile and often used per helical or herringbone. Second, internal gear pumps have a slightly different design. They feature two gears of different sizes, a smaller idler gear with external teeth and a larger rotor with internal teeth. The idler gear is kept in place using a pin and bushing. Here's how this type operates. On the suction side, as the idler and rotor teeth disengage, the spaces between them increases. This creates a vacuum that pulls fluid into the pump. The trapped fluid is then carried along the outer housing, guided by the rotation of the gears. At the discharge side, the teeth of the idler and rotor re-engage, reducing the space and forcing the fluid out under pressure. Internal gear pumps are self-priming, meaning they can start working even if there's no fluid in the pump at first. They can also handle high viscosity fluids like adhesive and paints and are bi-rotational, allowing the same pump to be used for both loading and unloading tasks. Third, gyroto pump. The gyroto pump is a specialized type of internal gear pump. It uses two intermeshing rotors with a gear-in gear design. The larger driven rotor has internal teeth, while the smaller idler rotor rotates inside it. Here's how it works. Fluid enters the pump through the inlet and fills the spaces between the rotors. As the rotors turn, the fluid is carried through the pump, moving between the tight spaces between the rotor teeth and the housing. At the outlet, the gear teeth are fully engaged, forming a seal and forcing the fluid out under pressure. Gyroto pumps are ideal for handling a wide variety of fluids, including those suspended solids or gases. They are highly efficient and work well across different fluid viscosities and temperatures. Applications of gear pumps. Gear pumps are widely used in the food industry for transferring various products, such as animal feed, molasses, vegetable oils and fats, sugar, cacao butter, and chocolate. In the pulp and paper industry, gear pumps are essential for pumping materials like sludge, latex, lime, kaolin, black liquor, lye, soap, and acids. Gear pumps are also commonly used in marine applications to pump fuel, lubricants, and hydraulic fluids in ships and boats. This pump plays a crucial role in the chemical industry, helping to pump a wide range of chemicals including isocyanates, plastics, acids, mixed chemicals, and sodium silicate. In petrochemical applications, gear pumps are used to transfer materials such as lube oils, crude oils, diesel oils, pitch, and both fuel and pure bitumen. Gear pumps are essential in the automotive industry for circulating various fluids, including engine oil, transmission fluid, coolant, and power steering fluid. The pharmaceutical industry relies on gear pumps to move fluids such as medicines, chemicals, vaccines, ensuring precise and consistent flow.
Gear pumps have several advantages. First, it has a simple design. Gear pumps have a straightforward construction, typically consisting of just two gears that mesh together along with an outer shell. This simplicity makes them easy to manufacture, maintain, and repair. The absence of complex components means that they are often more durable and less prone to failure, leading to lower maintenance costs. Second, it has a high efficiency. Gear pumps have very little internal leakage, which help them maintain a high level of efficiency, especially at higher pressures. Their positive displacement nature ensures that the pump moves a fixed volume of fluid with each revolution to minimize energy loss. Third, it has a constant output. Since gear pumps are positive displacement pumps, they provide a steady flow rate as long as the speed of the pumps remain constant regardless of system pressure variations. This is crucial in applications where a steady, predictable flow is needed. Fourth, it has a compact size. Gear pumps are relatively small compared to other types of pumps that can handle similar flow rates. Their compactness allows for use in situations where space is limited or where weight is a concern. This also makes gear pumps ideal for application in tight space or portable systems such as in vehicles or machinery. Apart from the advantages, gear pumps also have several disadvantages. First, it is not suitable for high viscosity fluids. Gear pumps tend to struggle with very high viscosity fluids because the efficiency decreases as the fluid becomes thicker. High viscosity fluids create more internal resistance, causing the pump to lose efficiency and increase risk of overheating. Second, it is not suitable for abrasive fluids. Gear pumps are not ideal for handling abrasive fluids because the particle can erode the gears and other internal components. This leads to increased wear and tear, which reduces the pump's effectiveness and lifespan. Third, it has a noisy operation. Gear pumps can be relatively noisy compared to other types of pump, especially at higher speeds or under load. The meshing of gears generates vibration and noise, which may not be ideal in environments where quiet operation is crucial. And lastly, it has a feed flow rate. Gear pumps provide a feed flow rate that is directly proportional to the pump speed, which cannot be adjusted easily. This means that any variation in flow needs to be controlled by adjusting the speed of the motor. This lack of flexibility can be a disadvantage in systems where varying flow rates are required. In conclusion, gear pumps are widely used in various applications due to its simplicity, reliability, and efficiency. Gear pumps are an excellent choice for many applications. However, it is important to select the right types of pump and maintain them properly for optimal performance.